Now, what I wanted to show you is how the chemist has enabled the fuel petrol to burn much more efficiently, and therefore how it burns inside a motor car engine. Now, for this purpose, I have bought a model of the inside of a motor car engine, and it's a tin can like this. Now, the reason why I've got a tin can like this is because inside the shape of a tin can is a cylinder. Now, inside every single motor car engine in the world, there are shapes like this which are called cylinders. And that is where the petrol burns. That's where the fuel burns. Inside the cylinder is a very tightly fitting piston which goes up and down inside the cylinder and is connected to a crankshaft which makes the engine go forward. However, I don't have a piston, I have a lid which fits on very tightly. However, for those of you who'd like to know, this is a piston from a real motor car engine. Every single motor car engine, lorry engine, bus, van, whatever burns a fuel, and they're called internal combustion engines, will have these things fitting very tightly inside cylinders, and they go up and down in a reciprocating linear motion, which by the genius of the engineer is converted to rotating motion to make the up and down movement to make things go round, and then the car engine can make the car move forward. So, what I'm going to tell you, that in a motor car engine, of course, the fuel goes in and then is ignited. Now, just for your information, inside a motor car engine, in petrol engines, we ignite the fuel with a spark plug, an electric spark. It's like a little miniature electric lightning flash. But in today's experiment, I, of course, will be igniting it with, there's a hole in the bottom here, there's a hole in the bottom there, and I shall be applying my light there. Now, what I wanted to tell you, and this is the key bit of information. If I were to ask you a question now, what is in this tin, you would be perfectly entitled to say, why, there's nothing in this tin, because it was full of paint, and now it's no longer full of paint. Of course, that's a correct answer. But from the point of view of combustion, from the point of view of burning, it is full of a most important commodity. And that, of course, is all around us. It is air. This tin is full of air, and I am now going to show you how the petrol burns differently when it is allowed to go inside that cylinder. So, we're going to now take our petrol here, we're going to take our teat pipette, and we're going to take pretty much the same amount, even that, just literally a few drops of petrol like that, and we're going to squirt them inside there. Now then, what we're going to do is put the lid on tightly, because the piston fits very tightly. There we are. Just make sure it's on properly, because the piston fits very tightly into the cylinder of a motor car engine. And I'm going to now hold this tin for just a few seconds. Now, while I'm holding this tin, the petrol which I put in inside as a liquid is undergoing a most important change. But it's not a chemical change. It's not burning. It's not changing into a different substance. It is actually undergoing a change of state. The petrol went in as a liquid, and now, after a minute or so, it has evaporated, and it has turned into a gas, and I will smell it. That smells pretty strong to me, and therefore that means that we shall be ready to conduct our next experiment. That means the petrol has evaporated and turned to a gas, and this is the important bit. It has now become fully mixed with the air. It has formed what we call an homogeneous system. And if we now apply our light to the bottom, please watch carefully and see if you can spot the difference, the color of the flame, or indeed the effect which is achieved when it catches fire. And there you are. As you see, I didn't quite see what happened, but the lid went high into the air. No, please, I'm not here. Dear ladies and gentlemen, do you clap every time you drive a car? No, but this is